All right, got myself a little hour and change here, hour or two to work on this OS dev a little bit more. But anyway, last time we got the save file function kind of working as start a base to work off of. So you see we have our new test file here. If I put it in to load it from the main shell, it's 1, 2, 3, 4, 5, 6, right? Then it loads, it just prints a T to the screen and it halts, which is why I can't do anything now. But we got that to work. So now I want to work on the load file. So if they choose an L when they open up the editor, it'll be create or load file. They choose an L, we want to go to load file. We could also, to make it easier, because I'm not going to remember, the user's not going to remember what all is on the system, we could probably call print file here before we tell them to load something. So let me do that. Well, I guess I should include that first, right? Yeah, we'll do that. Include print, we'll do print file table. So it'll be the same as the dir, the directory command in the kernel. So I don't think I did anything fancy for that, but we can see that just calls it and then goes back. Okay, so we can just call print file table and then hopefully that'll work. So let's find out here. Call print file table. Then we'll probably tell the user to put in a file that they want to load. So let's put it down at the bottom. Make another string, why not? We already got like 5. What's another one, right? Am I even using this? No, I'm not. Okay, let's get rid of it. Go choose file string or message. It doesn't matter. All right, choose file to load. Or let's call it file to load. We'll do this. So we'll move that to Ascii. Call it print string. So we're gonna hopefully print the file table and then tell them, you know, which one to choose. We might want a way of automatically getting the extension for the file that they choose. Like if they choose a binary file, like the one that we put in for the save file function, that just prints a T. If they choose a binary, we kind of want to load the hex editor to edit the hex bytes. Otherwise, we probably want to load the text editor. So we probably want to make a good way to automatically get that. But let's see if this works first. Let's move this stuff into like its own area. Let's make another thing. Put our code here. Call it input file name. After we loop through and get everything, we'll return. Okay. Of course, now I forget where I got that to begin with, but we can call and return. So that was for the save file. That was like right up here, right? Yeah. This would be to save. All right, but up at the top, where we're doing this, we'll put it here. It'll be to load. So after they enter in the file that they want to load, what do we need to do? We need to actually load the thing. We probably want to call load file, right? Let's do that. We'll probably load the file here. Load file from input file name. So we'll probably have to set up the calls to do it here. Or set up the params rather. Set up params to pass. All right. We're passing the memory to load the file data to. Well, I think, yeah, we're working with location 10,000 to save it from and to put the stuff in from. So we can load it to 10,000 as well. Or segment offset 1000 in real mode, but linear address 10,000 in memory. So the first param will be the file name. So we can push that. Editor file name. Push the address for that to get the file name. Second param needs to be the segment that we're pushing to, which will be 1000. And hex segment to load to. And then the third thing will be the offset, which is 0. 1000 offset to load to. OA, that's English. All right, so this only take, right now we're only using 3 parameters for load file, so that's all. All right, and then afterwards to reset the stack, we'll add, this will be 2 bytes each, right? So 2, 4, 6. We should be able to add 6 to the stack pointer. reset the stack pointer. So after we load, assuming we loaded the file successfully, I'm not checking for errors right now, but assuming we loaded successfully, we want to go to whichever editor is the right type for the file extension. So maybe we should pass an extension, or maybe we can pass it back in AX. In save file, we're using AX as an error return code. We could pass an address to an extension maybe, and then move it into the file type variable. We could do that, pass it back. I guess we could pass file type and then fill it out. So we can pass the file type as a parameter. Let's do that. That might make a little bit more sense. Let's do it after here. Let's make this the second parm instead. File type. File name. Let's do file type. That means we have to do 8 here instead. So where do we want to push the file type address into? We could use DX. We're not using DX in this yet, so let's do that. Might as well. This will be plus 8. Yeah. And then we'll have to change this to 10. Then we want to fill in the file type here, depending on where we find it in the file table. Okay, let me specify what registers we're actually doing. So we're doing these. I don't need to do this, but I think I don't need to do this, but it'd be a little better than push and pop A, I think. DX. So we need to move into something that we push the address to into editor file type. We have to get that back. How did I do that in here? We passed file type, the address into DX, which we then copied. So I could probably pass the address back. Of course, I don't have one down here, so let's make another one. This will be file type loading, I guess. So we're bad. This will be times 3 db0. We have our file type variable, so let's, I guess if we find it and we're loading it, and it doesn't error, so ESDI should still point to the file table entry here. Let's just put it up here just in case. Although it might not be true. If this errors, then it won't be true, but we'll just assume it's gonna be right now. So we'll do that. Get file type into variable, pass back number. So when we find the file, I guess we went through the whole file name, so let's put that back here. So this is after we've gone through the full file name here, so we're on this, because we're adding 4 down there on the left to get the track number. Well, to get the sector number to start reading at, which is the starting sector, which is this. So instead of doing this first, let's move bytes into file type loading variable. Oh, I can't move ESDI directly into there. That's always fun. Then we'll move into the file type loading variable, whatever's in AL. There we go. Then we'll do the same for, we can either increment DI and then move it, or we can do +1 and do the same thing, and then do +2. And this needs to be +1 as well. +2. Okay, so that should put the data into the address for file type loading. So file type loading variable should have the extension, hopefully, or the file type. And then hopefully we load it successfully, we jump back, we return to caller. How do I pass it back? If I wanted to use AX in the same way as save file as an error return code, I also need something else to pass file type back. We'll do setup AX return value. I guess we can just assume it's in another register anyway. Let's assume it's going to be in BX. So we can still use AX for an error code. So on return from load file, bx will have the file type, ax will have a return value. Compare ax to whatever. I don't know if it was 0 or 1. Actually, I think Vim has autocomplete by default, doesn't it? I should probably learn to use that. That would be good. So we can move into editor. Is it Control N? Yeah. There we go. Move into editor file type. bx. Well, the data at bx. Let's do this. We'll move into di, editor file type. Move the data at bx into AL if I can do that. I don't know if I'm allowed to do this. I don't want to store it. I'll move +1 and +2. Store string byte will increment di automatically. So what did I do for the return value from save file? I compared to 0. Okay, jump not equal and jump. Okay. Error and success. So let's just copy this stuff. Okay, that was after here. Do this. Except this will be load file error. This will be load file success. Let's make a load file error message. If they errored, we'll try to go back to the load existing file. You might want to reload the screen as well. Just do that, or clear the screen, whatever I said. We'll clear the screen and then we'll have them load again. Above though, okay, not like that. Put it there. We'll say go to editor depending on file type. So if it's bin, we'll go to the hex editor. If it's something else, we'll go to our text editor. So bin, how do we determine that? We can just check, I suppose. Do a very bad manual check. Which is okay. It's alright. Very bad manual check, but that's alright. So bx at this point also has the file type, right? Yeah. So maybe we can do this. We'll compare b. Let's make it let's do something like we did in the kernel where we had actual strings for each. I'll just put it here. This will be extension bin bin. All right, so let's move bx to Ascii. Into di, we'll do extension bin. Cx will do 3. And we'll repeat compare. So if it is a binary, then we'll the 0 flag should be set because everything's done, so we'll do jump equal or jump 0 to the hex editor. That means they loaded a binary file. We'll go to the hex editor. Alright, if not, we'll go to text editor. Simple enough. Okay. Simple enough, but we did do a fair bit of things, so any one of these fair bit of things that we just did could go wrong, and I'll have to debug. Symbol already defined inside of save file. Okay, print. Let's look at print file table. We got file size in here? Oh, we do. That's why. That's the only time it appears. File size section. Let's do that. Because it was a label inside a print file table. The start sector number. Let's clean these up a little bit anyway. It's the only time this appears. Directory entry number section. I guess I didn't really need labels for these, although it makes it more obvious, but Oh well, file extension I do. That's fine. That should work now. No. Undefined symbol, load file error message. That's true, we didn't do anything with that. Yeah, load file error message. Let's put that here. This will be load file error occurred. I could probably do something fancy and like combine these into one and just change the word from load to save depending on some condition, but I'm not going to do that right now because I'm lazy. But it should be the same number of characters. Undefined symbol, file table heading. File table. There's nothing else. Did I really get rid of it? It's only in the kernel, isn't it? Yeah, okay. Maybe we could put the file table heading. If that's the only time we use it, we don't use this in the kernel, do we? No. Alright, we don't use this in the kernel, so let's move this into print file table. Put it at the bottom. Variables. Alright. Let's do this instead. Okay. Undefined symbol, print blanks loop, nice. That's also only in the kernel. This is only here anyway, and this is called from the file table. Alright, well this doesn't need to be in the kernel then, if that's the only place it's used. I'll just put it down here, aha. And that makes the kernel slightly smaller too, which is cool. Alright, probably have another one, hex to ASCII, same thing. Alright, except I call H2A. When we do print file character. Oh, we use the same thing over here? Oh, I do. Oh. Hex to ASCII, let's make that an external file. Make it include, so we have disk, print, and screen. Let's make another, we'll make another folder here. I don't know, it's not, well, it's kind of like a header, right? The include file. I can make an include file for conversions between types. I guess I could call it type conversions or something. So we'll just make a directory. So let's make, in the include file, let's call it type conversions. We'll just do this for now. I called it hex to ASCII, so we'll call it hex to ASCII. So this will be convert a hex character to its ASCII equivalent. Alright, we did that just right here. Just put it here, hex to ASCII. I don't know how I want to lay stuff out. We'll just do this. Input parameter 1. Output 1 AL. Converted ASCII character. Because I want to structure things better. So if I forget what this does, there we go. Params, input 1 AL, output AL. So now we can include that. Hope it doesn't break anything on the way. Called this type conversions, yeah. So then we need to change print file table character. Or do we need to? We might not need to change it actually. But this calls hex to ASCII in here, right? Yep, down there. Let's just include hex to ASCII inside the editor instead of inside print file table for now. That'll call it. So include type conversions. I should have saved the line, so I wouldn't have to type everything out again. That's all right. All right, so what is broken now? Everything? Everything. File table heading. Undefined symbol new line, of course. Constants. NL equals 0xa, 0xd, 0. Hey, there we go. That works now, which means it might not work at all. Let's see if the file table prints. It does not. Doesn't print the heading. Interesting. 0h. Oh, I don't need a 0. The 0... yeah, that would probably be something. Some issue, right? Because then it would stop printing right after the new line. Yeah, that would make sense. That would make a lot of sense. Hey, there we go. That's all right. Okay, so that still works. So let's call the editor. Let's save like our previous function thing again. So let's make a new file, make a new hex file. AF4. Okay, let's save this as test file 1.2. Enter, and then we'll go back. So we should have test file here. So again, let's see, test file, 2 spaces, should print the T and do nothing. All right. And then it halts, so we have to restart it. But we have that there. So let's see if we can load test file. We'll just see what happens. I think the file will be loaded to the memory area, but we're not going to see it within the editor. I think after I load the file, I need to go to that location and like load it to the screen. If that makes sense, load the characters to the screen, converting hex to Ascii. So I'm not doing that, but let's see if it loads or writes an error, I guess. So let's load an existing file. So we print everything here. So what file do we want to load? Let's load test file 1.2. Okay, and then it goes, and it went to the hex monitor, so I believe test file is loaded to memory location 10,000. I just did not load the bytes to the screen, which I want to do, but that's okay. It's one step at a time. So I think if we run this with the $, it should print a T and halt if it was correctly loaded. And it didn't do anything, so that's good. Okay. Well, it did go to the hex monitor though, so let's see. I think it was right bottom screen message. Oh yeah, I'm always moving this in. Yeah, I don't need to do that. We can't tell if there's an error if it always just prints that. Alright, let's... Oh, we gotta enter it in again, that's fine. Save file error occurred. Interesting. I printed a save file error even though it went back. And it works. Oh, that's a bug we'll have to look at now that I have the errors printing. It might be printing it by default or something. That's something to consider. I don't know. We have a save file error though, that's not great. So AX was not equal to 0. Not sure. There was an error, but I don't know what the error was, which is great. Because it still wrote it. So AX was 0, because we're not moving a 1 into there. In load file. Otherwise there probably will be an error. Let's change that. I'm not carry return. Let's put it here. Although I don't have VP-2, do I? I like Vim, but I know what line I want to save. My fingers aren't doing it, but I know what line I want to save and do. It doesn't. Oh, move where? Well, let's just do the same thing here. Same thing here. Signifies error occurred, then we'll move that into AX. All right. Don't really need to pop it then if we're going to move it anyway, but we do modify it, so I guess we push it. I don't know. BX is going to be changed, that's life. We're going to move this into BX anyway, I don't need to pop it back. So now AX should have 1 if there is an error. Otherwise it might, well, it might have anything if there's not an error. Actually, yeah, let's change that back. If there wasn't an error, then we want to move 0 into AX. If there was, we want to move 1. If there was not an error, we want to move 0. Doesn't matter. Error. Or we'll call it disk write error. Let's call it that. That's if the carry flag was not set. So if it was set, let's go to return caller saving. Yeah, let's do that. We'll do that. This is if we were good. If everything was good, we want to do this. If things were not good, we want to handle the error here. So we'll move a 1. Okay. But we want to move a 0 in there by default, I suppose. So let's just do it up here. P minus 2. Let's move a 0 in there. Success will be 0. Let's do that. That way we should get actual errors, because before there could have been any garbage data on the base, or well, at that stack address. It might not have been 1, but it could have been something else that was not 0, so it's saying we had an error. Maybe we didn't really have an error or not. I don't really know. I think I just changed that for the worse, actually. Yeah, this does need to be jump not carry. Jump not carry is a success condition. Jump carry would be the error condition. So jump not carry success, and an error code to success. Otherwise it's 1, we move that. Okay. So now we can see what actually errors and what doesn't cause an error. Saying the word error too much, it makes me not realize it's a real word at this point. Let's see what happens. 4. Save it as test file 1, 2. That should be 10, right? Oh, now this is broken. We'll change that to 2048 then, which would be 4 sector, well, yeah, 4 sectors, 512 times 4, which means we still have to change the file table. This is 4. Let's see if that was our issue. Why does it not return? This is annoying me. That's not good. It goes back here. Stack segment's okay. ES. Yes, alright. So DI is editor file type. Maybe that's why. We have to reset DI. That could be why. When we call input file name. Except DI is changed right here to editor file name, so that should not be the issue. We put in 10 and it returns, but it's not returning to the part that I want it to. Well, I'm going to debug this and find out what happened, and then I guess come back and show you how I fixed it. So yeah, I'll be back when I figure this weird saving bug out. So I'll see you then. Okay, well obviously I'm more tired than I thought today, which is, I guess, to be expected. What do you expect from me? I need more coffee or something. It did work. Saving is working. It's just there's no error, so a message isn't being printed for error. It goes back to get next hex character in the code, which is why it goes immediately back to hex editor mode after we save the file. I'm confused because I guess I wanted a success message, even though I didn't make one. But it did save the file here. Well, I just tested and it saved the file here, but yeah, it is working correctly to save the file. I don't know what I'm talking about. Let's go back to here. It is going here and saving. It's just there is not an error, so it's going to success, and success goes immediately back to get next hex character. So when we go up to get next hex character, this stuff works. So I think what I should do is clear the screen and then go back. Clear the screen, print the thing at the bottom, which I guess is still there. On success, let's clear the screen. Call clear screen text mode. Let's move this stuff back. Well, keybind string. Let's yank that word and move it back. Call write bottom screen message, even though it's right underneath, that's fine. Alright, so clear the screen. So let's just test, yeah, dir. So stuff should go to sector 12 now for new ones, which is C. Save that as test file. We'll do 1, 2 to take up all 10 characters. Well, that's not right, is it? We messed up the extra segment or something. I think if we still do question mark, it'll go back. Yeah. And we have test file 2. So this will print a T in halts. We'll test file 12, which is what it does. Okay, let's see what loading, I know we messed that up, but let's see what loading does. Just for the sake of argument. And it did put it in C, which is sector 12, so that's good. So let's load test file 1, 2. Okay, it says load file error occurred, so we didn't really load it. And then it goes back to load again. Right? Yeah. Oh, we need to move CX. Aha, that's what it is. CX is whatever the max is. What is this? I need to get a better way of doing length. It's not 24, it's not 3. 56, that's what it is. All right, length of it, and then we'll do that. There's still a load error though. But this should at least ensure that saving works. So for test file 12, okay, then we go back, that's good. We have test file 12, let's verify it works. Let's load test file 12, load file error occurred. AX is 0, right? Well, it would be 0 here, so we got jump not carry. We got a carry. The carry was set when we loaded. This read did not work. And it's probably from the changes I did up here. I'll have to verify what DI is and make sure this stuff is right. I'll look into this and then I'll get back when I figure out the issue that is causing a carry here, so it's not loading correctly. I'll try to figure out why it's not loading correctly. Okay, so I didn't find the exact issue yet for this loading error, but I did find a few things we could probably change to be better, because I'm not thinking fully clearly from some mistakes I'm making in my code here. So I got the load file open, and I'm going to, I guess, clean up stuff a little bit, try to make it work a little bit better. So let's just see, we'll go from the top. I'm pushing BX, FS segment, DX, and SI. At the bottom, I know I took out BX because I'm moving something into there, but I didn't consider that we're popping it because we're pushing it to begin with at the top. So that would mess up the stack. So that would be part of why this could be non-zero for the load file errors. So let's just change that. Also DX. I know I wanted to use DX for the file type, but I'm not really doing that. I'm pushing the file type, which is empty right now. Over here it's empty when we get to here, because we don't know what file type we're loading until we load the file. And I'm moving file type loading into BX after we fill it out. So there's really no point in passing it because it's not going to matter. So I'm not going to pass it because, yeah, it doesn't matter. We'll go back to the 3 parms. We'll go back to the 3 parms because, yeah, we're not passing it to begin with. There's no point here. Okay, so we don't need DX. Offset segment file name is fine. And this will be, go back to 8, and this will be 3rd. So we could also make our loop a little bit different, maybe. Because I know I changed the loop and stuff a bit in save file, but I did not replicate that inside of our load file. Just replicating, you know, just duplicating code. The dry principle has no effect on me. Let's just do the opposite. This is the wet principle. This is, I don't know, write the same thing always. WSA principle, not dry. All right, restart. We move file name loading to SI, pop DI, and we'll add 16 instead of going to the next character, and then we'll jump. All right, if it's ever 0, we'll go to the end, otherwise we'll compare. If we compared and everything is good, then we found it, and we'll go to file loading. This needs to be loading. So +4 should be the starting sector, +5 should be the file size. So add DI4, that should be the starting sector. But what we can also do is do a +4 here and not do that. Don't increment it. We got the segment, that's okay. Number of sectors to read, this can be +5. We'll just do offsets from where it's at. Okay, and then it should read into ESBX. So BX is set. BX is 0, right, from up here. Offset, we pass 0, then the segment should be 1000. So that goes into ES. ES is 1000, BX should be 0, so that should be 10,000. It should load the sector, the one sector to 10,000. And N13, then that should be okay. And we'll return. This should be 6 now. So maybe it was just because of that beginning BX, I had to pop that off to get the right stack value into AX. That could be it. It puts a far return in there when we run it. Okay. So even if we loaded the file correctly, and we just want to run it without overriding anything, it would immediately put a far return in. So I think, yeah, we probably want to change it to where we load the bytes from the file to the screen so that DI is pointing to the end of it, and then we can put a far return if we want to run it. This also means everything's going to end with a far return if we want to execute and then save something after we run it. But let's focus on writing the stuff to screen first. Let's get rid of this. It should load it correctly. Actually, let's test that. Before I mess with that, let's test that it loads something. So load test file 1.2. Load file error occurred. Why does it say that? So I might could make a little test or something print out if it didn't find it. So that way I could tell, did it not find the file name? Or did it find it but not load it correctly? Let's make this. Make a file not found label. And I don't know if I'm actually going to use this, but I'm just going to put a little debug thing here. So I'll do debugging and debugging. And we'll just move, 0E. We'll just print a little T out for testing. If it was this thing here, and we'll jump to file not found. So if it prints out a T, then we know we have an issue. And we reach the end of the file table without finding the file we wanted to load. And it'll move and it'll go back. I'm going to halt after this too. Alright, let's see if that is the issue. Alright, load test file 12. No, it printed the T. So it didn't find it within the file table. I guess we don't need to, even though it's still broken, we don't really need to do these two things if Ascii has the file name. We can just move that into DI. Instead of popping that. This is a loop. I do want to push DI here, because that saves the file table entry that we're at. Popping where DI was at, then adding, then going to check. Get rid of, let's put that here. If we're going to move the same one to EL anyway, if it's not 0 and it is equal to Ascii, then we'll go to here. So it's already equal to Ascii at this point. I know I could do compare string byte in here. Since I'm comparing basically Ascii to DI, I could probably use compare string byte to make this easier. But if CX is 10 anyway, we could probably reset. Do it like down here. So if we want to set into DS, we can't set immediate values into DS. So we'll try. Where's the program? 800, right? So 8,000, 800, 0. DSSI compared to ESDI. I guess we'll try that. We can do compare string bytes. That will automatically decrement CL or CX here. not equal, we can go there. Otherwise, it is equal. We should be able to go to found file loading. Right? So repeat 10 times, compare Ascii to DI, increment both. Ascii should point to the file name we want to load. DI should be the file table. Start of the file table entry, which is the file name. They're both 10 characters long. If they're not equal, it'll go here. If they are all equal, it'll go down here. So if they're not equal, then we'll reset Ascii. We'll pop DI and go to the next one. Jump file name loading. Okay. Not that this would make it actually work, but that conceptually is easier. Let's try that over here. I don't know if it'll work for save file. Let's find out. Let's find out. Otherwise, jump 0 is the same as jump equal, but I'll just do that. And so let's go ahead and break everything else that was working, right, while we're at it. That is shorter, and it does make sense. I guess we'll see if saving works, and if that works, then that's a sign that this does work. It's loaded, otherwise it wouldn't show up there. Test file, space. I really don't get it, but saving did work with the compare, so I know the comparison's fine. Oh, okay, let's do this. Let's make sure my testing is sound. We'll move this all the way down here. That way we know that it isn't being called from this point. If it's called from an error here, it'll go, here, and then it'll return. But if it is actually being called from up here, then it will be called. It's the only point. If it reaches the end of the file table, it'll halt and print a T. If it doesn't reach the end of the file table, then it'll go on. We'll see if it's another error or not. Yeah, it prints the T, so it doesn't find it at that memory location. But it is in the memory location, otherwise it wouldn't be in the file table and it wouldn't have loaded. Okay, well, I'll go try and debug this and find out. So I'll see you soon. Okay, so I found my load file issue. It was a couple, dumb mistakes, but it's easy for me to overlook. It's hard to do this when you're talking and trying to walk through your thoughts at the same time. You miss really probably obvious things, but anyway. You notice something here in the editor, this restore extra segment here. I was doing that for the save file code here. I was doing it there when we save a file, but when I was loading a file, I was not doing this. So extra segment was not set to the program space, which is 8,000 in memory. It was set to, I think, the kernel space or somewhere else, which is 2,000. So this was not working. It was not working to input the file name correctly. So an input file name, right here, we're restoring to DI. ES was set to, I guess kernel space, which is 2000. So 2000 DI instead of 8000 DI. So it was not storing inside this file, the editor file name. It was some other garbage location. And since that was not being put in right, this editor file name here, this address was not really the right address. So when we called load file and it loaded the file name to Ascii, it was all basically blanks or zeros or just garbage data. So when it tried to find that in the file table, it didn't find it and it ended. So I felt like a big stupid head, but I found that out after much trial and error. After we got the file name, down where we're loading everything, the only other issue, so I changed this. I don't think I have my debugging stuff. Yeah, I do. I was printing out hex values to debug. So I switched this around. Before I had move FS into AX and then move that into ES, but I had that before the number of sectors to read, so it was kind of like, it was like this before. This was AX. So this is what it looked like. Now, I'm using ESDI to get the number of sectors, which this value is correct, right? It's C for this one because it's sector 12 is where it starts at. But I'm changing ES here to the value of FS, which is 1000. So ES is pointing to 1000, BX is 0, that's pointing to 10,000. But if we're trying to get the info from the file table, We need to point to 1000, not 10,000. AL here, this ESDI was not correct for the file table, so this was 0, and you can't load 0 sectors, so we're getting an error automatically. So I changed this to DX, and then we're just XORing DX here anyway for the drive and head number for the time being, so that this AL is correct. After I move this, move it below there. So then we change ES, so this ES and this ES are the same, so these point to the correct values. And then we do that. The only other thing is, I think I changed the label here, file load error. So I changed that label. This label appears file load error now. But I think those are the only changes I really did ultimately. So yeah, but that allows the stuff to work. So we don't have anything. We're gonna put in a new file. B054. So 54 is capital T. Maybe I press something else. Yeah, there we go. Capital T. Okay. So if we load the file, test file, well, that didn't work because that, yeah, entered it in wrong, but that's okay. Test file space space. We loaded it correctly. It goes to the hex monitor. So it doesn't run when you do run. You know, just the $sign doesn't do anything. So if we don't input anything and we go to run, it would be execute input. We're putting a file return in there. So by default, the first character is a file return, and if we immediately execute that, it'll return immediately. So that's why it doesn't do anything. First character is being replaced with a CB. So I want to change, when we load the file, I want to load the bytes, print them to the screen, and then I guess we'll move the cursor back to the start. We'll move, I guess, the cursor all the way to the end. I wanted to move it to the start in case you wanted to overwrite, but we can do that later. Let's just print the stuff to the screen and then try to run it and see if it works, right? Let's do that. Let's change this clear screen here. Let's put it somewhere else. Let's make another label, of course. We'll call it new file hex or something. New file hex. And all this is going to do right now is call clear screen text mode. And then it's going to jump to hex editor. All right, this way we don't clear the screen in there. We do it somewhere else. And then I'm also going to make, I guess, load file hex. Jump equal hex editor. Let's make a load file hex label, which is where this will go. We do still want to clear the screen though, I believe. We just don't want to do it in the hex editor. We want to do it after we write our stuff, so. I don't need to restore it here. I don't think I need to restore the extra segment here because I'm changing it right here anyway. There's not really a point to doing that. But before we get the character, we are resetting it to here. So let's do this. We set the location, the file location. So I want to read the bytes from that location. I want to print them to the screen. So let's move. Well, I might make a little loop here. Let's move ESDI. Well, I want to move that into AL. So this is a binary, assuming everything is hex bytes. Let's move the first hex byte into AL. We'll call hex to Ascii. That will convert the hex into the Ascii equivalent, and then we want to print it to screen. So I guess we can move 0E again. I really need to make like a print character function, I think would be good. That's all right. Whenever CX is 2, we want to do put hex byte. Except we don't want to put it in the memory area. We just want to write a space. So I think new file hex editor will put this code into. So if we load it, we'll put this under the new file so that if it's a new hex file, then we'll reset this to 10,000. But if it's a loaded hex file, if we're loading it, we don't want it to be 10,000 because that'll be overriding by default. We want it to be 10,000 plus, you know, whatever bytes we're going to write. So we'll increment cx. If it's printed out 2 bytes, then put space. Otherwise, jump loop maybe? I don't know. Put space, we'll XOR CX. Every 2 characters right now, I want to put a space. Like when you're editing, I want it to print out the same way so that it looks consistent. We want to read a B. If we enter a B and a 4, we want to read to the screen a B and a 4, but it'll be stored as B4 for 2 nibbles. So I have to split the byte and get each nibble out. I can AND AL with this, maybe? That should only keep the first nibble out of it. If we then call hex to ASCII. Although hex to ASCII already moves 0E into AH, but that's fine. So print out AL, okay, and then we'll move it again. But this time we'll get the second nibble, we'll AND with this. We'll do the same thing. So yeah, some duplication of code here, it's alright. We'll do that, and then instead of messing with CX, we'll do this. We'll put a space. Then we'll jump to the loop. We'll get the byte, we'll AND it to get the first nibble, we'll convert that. We'll print it, we'll AND to get the second one, convert that, print, and then we'll put a space and print. And then we'll increment DI. How do we know when we're done? You know, we don't have an exact byte counter. We're just doing it by sectors, really. So at this point, we're gonna have loaded like 1 sector. Let's move this for now. Loop, so I need to change this, of course. Change to actual file size. Change the actual file size. We'll say it's 1 sector for now, so we'll do 512. I guess when we go to save, we need to pad it out to 512 as well. But hopefully that works to print it to screen. There will be a bunch of zeros, but that's okay after we pad it out. Let's say after we load it, we want to go to get, yeah. So we'll go to the regular editor after, or well, we'll jump to the regular, not that, we'll jump to the regular hex editor after. To edit the file if people want to. Alright, let's just decrement DI. Yeah, we'll do that. If that makes sense. It might be one off at the end. I don't know if it will, but I'm just gonna prevent that by doing that, hopefully. And then we'll go to the hex editor to actually edit. The only thing with that is, let me get rid of this on the screen too. We have to pad out to 1 sector if we save the file. Let's make it a word. Because 1 byte only goes to 255, 512 is greater than 255, so let's make it a word. I might regret that decision when everything breaks, but let's make that a word. This will be DW. So before I restore, let's fill it out, if that makes sense. We want to fill out the rest of the sector for the file that the user's typing in. If they didn't fill out a full sector's worth, we want to fill it out, pad it with zeros. So if they typed in like 300, we want to fill in 212, zeros to fill out the sector. But if they typed in like 700, we want to fill out to 1024. I kind of want to do this. Divide file size by 512. We have to set up the file size into AX and DX split, and then we do divide, and then the quotient will be in AX and the remainder would be in DX. It'll probably just be a lower half, so I could probably just move it to AX since it's just a word. So let's do that. So the file size, the lower half will be in AX. Okay, and then we can divide by 512 to get the sector size. So we have to compare what value we get. If the quotient is 0, then we have less than one sector typed in. Otherwise, if the quotient is greater than 0, we have at least one sector typed in, if not multiple. Then the remainder, if the remainder is 0, we are exactly on a 512 byte boundary, so the file size is exactly 1 or 2 sectors or 3 or however many. If we have a positive remainder, that means we're somewhere in between sectors, so we'd have to get the difference to the next one. I guess we'll do that. Compare AX to 0. We'll go to fill out one sector. Okay, we need to compare dx to 0. dx is 0, then we haven't typed in anything, it's an empty file. Let's change this to check. Check if one sector. Let's indent this as well. Fill out one sector. Else we haven't filled out anything. If they haven't filled out anything, we'll just fill out 512 bytes of zeros, I guess. Fill out one sector. Let's just do this actually. Otherwise we'll fill out the whole sector, so. We could do this AL 512 byte zeros, okay. Then we'll go to here. Jump, enter file name. All right, we need to fill out less than the sector, so we need to move into CX in this point. Whatever dx is, it's the remainder minus 512. And this is only if it's one sector too. I'll have to do different things if it's multiple. Yeah, I'll do that. Move CX 512, and then we'll subtract CX dx. That'll be 512 minus whatever's in dx. And then we'll do the same thing here. So if there's no quotient and no remainder, the file is empty. No byte has been entered yet, and they want to save it. So we're going to fill it with 512 0 bytes, 512 nulls, right? And then we'll enter in the name and we'll be good. Otherwise, we're going to enter in the remainder of the sector, which is 512 minus whatever was currently entered, which would be in dx. And then they'll enter in the file name. So if AX is greater than 0, then we need to see how many sectors they filled out, which is whatever's in AX. We multiply by 512. We want to put into CX, we want to put into AX multiplied by 512. So that's how many sectors they filled out. So if it was like 2, it would be 2 times 512 we put into CX. All right, and then we're going to check DX to see if they filled in, none, and we're good to go, or, more than none. So if they didn't enter in anything, we're good to go. We don't have to worry about it. Otherwise, we do need to fill out the rest of the sector, so we'll subtract CX, DX, we'll XOR AL, and we'll repeat store string byte. Actually, we just need to input the DX number of bytes. 512 minus DX is all we have to do. If we do 512 minus DX and fill out the rest, then we would be good to go. We can do this. There we go. So does that make sense? Or I'm getting the sector, I guess I don't really need to do this, that's fine, but it doesn't matter. I'm getting the sector count, and then I'm checking the remainder if they filled out partial amount of sectors. If it wasn't partial, it is exactly 0, then we're good, we don't have to worry about it. If they did fill out only part of a sector, we need to fill the rest of that one sector out with zeros. And since at this point ESDI should be pointing to, you know, the location in 10,000 where the file is, we don't need to offset from that point, we just need to fill out the rest of the sector. So that's what I'm doing. Hopefully that makes sense. We don't need to do other complicated stuff I was thinking of. But that should be good. That should fill out the rest of the sector. If they didn't, even if it's 0, should fill out the one full sector of zeros, otherwise fill out the rest of the sector with zeros. And then they go to enter in the name. So that should be all right. That means we don't need this jump. So that means when we load it to the screen, we should see everything with a bunch of zeros, hopefully. Let's find out. Let's see what all breaks. I probably forgot something. Loop is illegal because it's by itself. Yeah. Let's put a colon there. So it's actually a label. Div 512 is invalid. Okay. What do I have to put there? What is the operand? General register or memory. But it might not be immediate. It didn't say immediate value. Although imul allows an immediate value. So it needs to be a register or the memory within a register pretty much. For div. So I can't do this. I have to do a register or memory within a register. This could be CX, couldn't it? Or it could be BX. Yeah, let's try that. Let's move BX 512. We'll divide by BX. There we go. So it has to be in a register or the memory in a register, which is the data. So if you moved 512 into bracket BX, then you could do div bracket BX, but we just moved it into BX, so that's fine. So let's see what all does not work now. Well, that doesn't work, obviously. Is that wrong? No, I'm not clearing the screen there anymore. That's what it is. New file hex. There we go. See, B, aha, there we go. So B40E, B054, CD10, FAF4. This is wrong down here. Not being set to video memory. So that's not good. Okay, so after we write the bottom screen, we need to move ES back. Just move this back here then. I just wanted to prevent it from clearing the screen if it was new, or whatever, if it wasn't new. Let's move that. Oh, a bunch of zeros. Well, it did load 512 zeros. I didn't want it to do that if it was new, though. But we do know it loads a sector all right, so that's good to know. Loads a sector zeros. One step back, 2 steps forward, right? Or the opposite? Probably the opposite. Oh, then it goes to load file immediately. That's why. That's why this needs to go to hex editor right after this. Yep. Then it would continuously do that. Okay. It would help if I read the stuff I'm doing before I like try to test it and it doesn't work. That'd be nice. Let's load test file. That did not work. I should have cleared the screen first actually, and then loaded the bytes and wrote them to screen. We know it successfully loaded the file, but BX was not a bin, or else it would have cleared the screen when it went to load file hex. So this compare did not go all the way through. So ES is pointing to 1000, so we have to move ES back after this, I believe. So when it loads the file, it loads to 10,000, so ES is set to 1000, and then offset 0 in BX. We can put it here, I guess. Restore the extra segment, so ESDI points to the correct editor file type. I think that was the issue. It's always the extra segment. See, I'm getting more... It's getting a little bit easier to determine if it is an extra segment issue or not. I'm getting more familiar with it. But not as much as I need to be. slowly getting better at assembly programming. Not great, especially this OS stuff where I have to keep everything in my head at once. But this will be, I mean, we'll get better at this stuff eventually. We're on the way. We're getting saving and loading done. That's a big step. After this is in a good place, we can do some more exciting things. But we got to get this loading first. There we go. Hey. There is garbage at the top, but we are loading a full sector. So only thing left to see is if it runs and prints the T and halts. And it does not. Doesn't do anything. We can enter in other stuff though. Okay, so we do have garbage at the top. Figure this would be there. So if we're working with B4 and 1 byte, that should be that, right? Because that's 0, 1, 2, 4, and 8 is 12. B is 11. Never mind. B is 11. So that would be this. No. Be this, right? 8, 2, and 1 would be 11. Okay, 2, 4, and this would be 4. So if we AND it with this, you figure this would be, it would end up as 1, 0, 1, 1, and all zeros. Oh, but I want it to be in the lower, the least significant bit, don't I? Yeah, that's probably why. I probably need to switch this. I need to rotate it. Yeah, let's do that. Let's rotate right by 4. Rotate right 4 bits, which will move the 1011 into this place. Hopefully this is 0. I don't know. If it's not 0 though, I can make sure it is by ANDing it with 1, 2, 3, 4, 1, 1, 1, 1. And that'll definitely make these 0, and this should be the same. Although the second one worked, probably because it was already in this. I guess. This one is fine. It's just the first one we have to rotate. This one is fine, because the 4 printed out, I'm pretty sure. It didn't run when we tried to run it anyway, but I just want it to print out correctly first. Then we can worry about the other part of it not working. We'll load. That didn't work. That didn't work. At least I can keep trying. Although I need a key to actually exit. Okay, there we go. Yeah, that's all I had to do. I had to load it into the lower 4 bits to have it work, which makes sense. So B40E, B054, CD10FAF4. So the only issue is that I wanted to run this with $, and that doesn't do anything. I know when I run it, it'll put in a far return, but that should be at the end of the file where the cursor is right now. So let's see. Maybe I never did change that. I guess if we load the file, instead of jumping to hex editor, we can jump to get next hex character. That way it won't zero it out. We do want to write this still. I know I'm still duplicating. Eventually I'm going to go through and clean this up, I promise. It'll get really annoying looking at it one day. I'll be like, this is crap, and then I'll rewrite it, but that's not going to happen right now. Let's put this here. All right, we'll just duplicate. And then instead of going to hex editor, if it's a current file that we loaded in, we'll go to the regular processing. Whatever we call it, get next hex character. All right, that way it won't zero out DI. So when we go to run it, execute input, this will be at the end of where we're at. Let's load. Okay, so we got our file loaded. So let's see if we do $, it should print a T and halt. And it does. Hey, I know this is bad. I don't want this. I probably need to reset DI again or something, because that's not good. Or ES, I need to set somewhere, but it prints a T and it halts. So we are now able to save hexadecimal bytes to a file and view it in the file table. And we are able to load those bytes to the screen in our hex editor and then run the code. So we can save and run code now. I do want to mess with the editor some more so that we can, maybe move the cursor back, override it, and then make this a little bit of a better editing experience. Maybe using arrow keys or something and moving like a byte at a time, or putting in backspace support. Maybe putting these 2 bytes at once instead of 1 byte at once. Since if we didn't clear interrupts, it probably would return, but since we cleared the interrupts, the halt makes it actually halt. Oh, because it writes to the bottom of the screen. Oh, this sets ES. And then when we go to get the next hex character, when we execute, we're calling 1000, but we're setting this. So ES is not set after we write the bottom screen message. Okay. We need to reset ES again. Probably to 10,000 if we want to keep entering characters there. Yeah, this moves DI. So we need to reset ESDI after this. So we probably need to save it off. But I'm just going to save it here. We'll do save DI or whatever. Because it's a word value currently. I guess the same thing for ES. Although ES is 1000, we may just need to change DI. Yeah, ES is going to be 1000 for the file. Load file hex. So before we do this, save off DI first, then we write the stuff. Hopefully AX is okay. You go to get, well, we're X oriented anyway, so yeah, we can use AX here. And then we'll move back into DI, save DI, reset. We should do restore. Can we do that? We can do that. Nice. All right, so just one more time. There we go. Now we don't get any garbage down there. Okay, so all right. This has been about between 3 and 4 hours, so it'll take me a while to edit this down. Probably another week, hopefully less. We'll see. We have basic loading and saving of hexadecimal files, so binary files. I want to do a couple more edits to the hex monitor, like restricting input to only the hex bytes, and maybe a little bit easier, maybe moving around with the mouse cursor too. I'm not sure. I also want to go towards, you know, making a sort of regular text editor that we can at least put other kind of files, text files or source files in. If I want to eventually make an assembler or a compiler for something, or try and port a really tiny basic one over for some language. And then I can write it and we can save in text files and then load and run those somewhere. I could also I have a couple more shell, or shell commands. Now that saving and loading works, I can probably try to put those into the shell and make commands for like deleting a file or renaming or copying or just printing to screen as Ascii, which is what this is doing when it's loading. Maybe also a help or a list commands command that lists all the commands because I forget what we have. I can make print character, print string work without the BIOS interrupts, which will be changing, all the files, but it'll probably be good to move towards that. Just writing directly to video memory everywhere, making it consistent, make it consistently called everywhere we print something. Other things, maybe changing save and load file to work without BIOS interrupts, or doing other things without BIOS interrupts, and then moving to 32-bit mode and changing our graphics mode to have an actual big screen instead of this tiny text mode screen. But yeah, so sort of hopefully exciting things ahead. I'll probably do some editor changes here, some hex editor, and maybe move on to basic text file entering text editor changes. Maybe I'll do that next, but we'll see. It might be something else. You can let me know if you want to see shorter videos or longer ones. I kind of try to make it consistent. Like if this is a load file video, I want it to be making the load file to getting it to run, even if that takes a couple hours in the video. I want it to be, like a whole finished sort of idea, a finished section. I don't want to leave it halfway in the video. It's kind of frustrating. If you want shorter videos, I can try to chop things up into shorter things, like do a command that takes like 20 minutes to implement or something, instead of these multi-hour long things. But anyway, thanks for watching. I do appreciate it. Hopefully you find this interesting or exciting, but we got something working, so that's good. Yeah, I'll see you on the next one.